Hello everyone, today we continue our tutorial on how to create open door. Go to content, add new folder, name it leg. Right click blueprint class, scene component, name it BP leg. Right click blueprint class, click on all classes, choose actor component and select. Name it BP leg manager. These two blueprint is responsible for the procedural animation of the leg. Right click on miscellaneous, click on curve, select curve float and select. Name it step height curve. Open it, right click, add key, and when its y-axis is 1, right click, add key, move it up to 1. For x is 0, y is 0, and for x is 1, add key, y is 0. Select all these keys, right click, auto. Press F to zoom it. Right click, add curve, select float curve and select. Name it step speed curve. Open it, add x is 0, add key, y is 0, and when x is 1, add key, and y is 1. Select all these key, right click, auto. Go to third person character and viewport. Click on capsule component, add BP leg, rename it to BP leg left. Duplicate it, Ctrl D, name it BP leg right. Go to BP leg, add variable, name it leg manager. Variable type is BP leg manager. Object reference, and go to third person character, event graph, create a begin play event, get BP leg right and set leg manager, get BP leg left, set leg manager. For the leg manager, get BP leg manager, connect it to leg manager for both of it. Go to leg manager, add new function, name it can leg and plan. Add input, name it leg and select variable BP leg and object reference. BP leg object reference. Add variable, name it legs. Select variable type is BP leg and select array get legs. For each loop, connect it to can leg and plan, and go to leg blueprint, add variable, name it is planted. Select variable type to boolean and add new function, name it update food. Go to leg manager. For the array element, get is planted, the leg is not equal to the array element and call n boolean, connect it to n, create a branch, connect loop body to the branch, and call return node, connect true to the return, add output, name it can and plan, and variable type to boolean and set it to true. When the for each loop complete, copy this return node and paste it, set the can and plan to false. This one we don't want the two of the leg to plan in the same time or unplan in the same time. Add new function, name it get leg reference. Add input, name is leg tag, and the variable type is string. Get owner has to third person character for the leg tag or switch on string. Add pin like the switch on string. The pin name is left leg. Add new pin name right leg. If the leg is left leg, we call BP leg left. Get BP leg left. Call return node. Add output. Name it out leg. For the variable type is BP leg object reference. Copy and paste it. Connect the right leg to the return node and connect BP leg left to out leg. Call BP leg right. Connect it to out leg. And add new function. Name it get component reference. Get owner has to BP third person character and call get BP leg left, call get BP leg right, get legs, add array, add leg left, copy this and add leg right to the legs array. Call return. Go to event graph. For the begin play, call get component reference. Call get component reference. And for the event tick, we call up and create new custom event. Name it update or leg. And for the event tick, call update or leg. Get legs. For each loop, for the array element, call update foot. Connect loop body to update foot. Go to BP leg, add variable, name it debug draw, and set variable type to boolean. Add new variable, name it array start. Variable type is vector. Add variable, name it array end. Add variable trace position. Add variable, name it array cast length. Let variable type to float and compile. Set default value is 10. Add variable, name it 1 to replan. Set variable type to boolean. Add variable, name it foot position. Set variable type to vector. Add variable, name it stop distance. Let variable type to float, compile, and set stop distance is 10. Add variable, name it do replan. Variable type to boolean. Add variable, name it percentage replanted. Select variable type is float add variable, name it stop time, and compile. For the default value is 0.55. Add variable, name it replan speed curve. Select variable type to curve float. Select object reference. Add variable, name it replan high curve. Compile. For replan speed curve, select step speed curve, and replan high curve, select step high curve. Add variable, name it stop high. Compile. Select variable type is float. The default value is 50. Add variable, name it plan start position. Select variable type to vector. Add variable, name it target position. Add variable, name it put position no high. Add variable, name is planted. The variable type to boolean and compile. Set it to true. Add variable, name is time since and planted. Variable type to float. Add variable, name is anim instant. The variable type to anim instance. Object reference. Plan start position variable. Category, rename it to internal. Target position, choose internal. Put position no high, internal. Category is planted, internal. Time since and planted, internal. Add new function. Name is get put target position. Get put target location. And create a sequence. First, we get the location of the put. Then set it to restart. Get the transform. Break the transform. For the rotation, get forward vector and multiply it with the raycast length. Right click, add the vector, convert pin to float. Connect the raycast length, get restart, add it with the forward vector and set it to the ray add. Add macros, name it hash ray. For input, add input, name it ray start. Select variable type is vector, add ray add. Variable type is vector 2. And for the output, add new variable, name it location. Add new variable, name it true. And variable type is execution pin. Add new variable, name it false. Call line trace by channel. And for the input, drag it to the input and move it up. For the execution pin, ray start, connect it to start, ray add to add. Draw debug type, call select. Get debug draw and connect it to index. For false is none, true, call for one frame, select for one frame. And return value, create a branch, connect it to true, connect it to true, false, connect it to false. For out hit, create a break hit result, and the location, connect it to location. Get full target location function, add pin and call cast ray. Get ray start and get ray add, connect it to ray start and ray add. Set trace position, connect location to position. True, connect it to set trace position. And if false, we copy this cast ray, connect it to cast ray again. Get ray add, connect it to ray start. Get ray cast length, multiply it with 4. Right click, make vector, connect it to that vector and get array add, subtract it with the vector that get from the that value, connect it to array add. Get target position, set trace position. If it's true, we set the location of the array add to trace position. If it false, we set the target position as the trace position. And add pin, get trace position, set target position. Connect the DAN 3 to the target position. Add new function, name it check for replan. Create a sequence. Then get put position, subtract it with target position. Call vector length greater than get stop distance. Then get is planted, call and boolean, connect greater than to and boolean. Set 1 to replan, connect it to the sequence. Get leg manager, call can leg unplan. Go to our leg manager for the can leg unplan, set it to pure function and go back to our leg blueprint. For the leg we choose shape and get 1 to replan, call and boolean, connect it to and set do replan. Add pin, get do replan, create a branch and connect it to the branch. And if it's true, we create a sequence. Add pin, set is planted to false, get put position, set plan start position, set time since and planted to 0. Add new function, name it take footstep. Get is planted, create a branch. If it false, create a sequence. Add pin, get time since and planted, divide it with stop time, then set percentage replanted. Get plan start position, love vector and get target position, connect it to the second vector. Get replan speed curve, get float value, get percentage replanted, connect it to in time and connect it to alpha. Then set put position no high, connect it to then 1. Get replan high curve, get float value, get percentage replanted, connect it to in time, multiply it by stop height, make vector, connect it to z value, get foot position or height, add it with the height from our curve, set foot position, connect it to the sequence, get time seen and planted, add it by get birth data second, add it with time seen and planted, then set time seen and planted, connect to sequence, get time seen and planted is greater or equal to stop time that is planted. Add new function, name it debug draw. Get foot position, then call draw debug where. Set foot position to the center and radius is 4, segment 12, line color green, duration is 0 and thickness is 2. Go to update foot function, call get foot target location, then check for replan, take footstep, get debug draw, create a branch, call debug draw. Go to event graph, at the begin play, get world location, then set foot position, connect it to begin play, get player character, pass to third person character, get mesh, get anim instant, set it to anim instant, add custom event, name it set default position, call get foot target location, then get trace position, set it to plan start position, then set it to target position, then set foot position and set is planted, set it to true. Go to third person character, click on BP leg right, set x to minus 42, y is 4.26, z is minus 80, and set debug draw to true. For the raycast length is 20, stop distance is 10, stop time 0.5, and stop height is 12. Go to BP leg left, click on BP leg left, set the location x to minus 3, y to minus 11.29, and z is minus 80, and set debug draw to true. The raycast length is 20, stop distance is 10, stop time is 0.5, stop height is 12. Click on the mesh and go to ABP Queen Animation Blueprint. Open ABP menu. Then create begin play event. Get owning actor. Call get component by class and select BP leg manager. Right click and promote to variable. Name it leg manager. Get leg manager and get leg reference. For the leg text, set it to left leg. Then copy and paste it. Leg text is right leg. Promote out leg to variable. Name it left leg. Duplicate it. Name it right leg. Set the right leg to the out leg of the right leg text. Connect it to get leg reference and leg manager to target. And for the cast to character, we cast to third person character. Change it. Character. Set the variable to BP third person character. Change variable. Compile. And let's play test it. Now we get the position of the foot. Find our control rig by go to third person character blueprint. Click on the mesh. Search for anim class and open ABP menu. Select on anim graph. Click on control rig. Scroll down and for the control rig class, click search browser. This is our control rig. See all many basic foot IK. Duplicate it and name it see all mannequin at one foot hand IK and use this control rig instead. Drag it inside control rig class. Open this new control rig. Click on rig hierarchy. Click on root. Right click new control. Rename it to foot control left. And for shape property, choose circle stick. And the scale of it is 0.2. Click on initial. X location is minus 15.6. Y location is 4.3 and Z is 0. Copy it, compile, and then click on the foot control, duplicate, control D, foot control right, and then set the X location to 15.6. Compile, click on my blueprint, add new variable, name it left foot position. The variable type is vector. Duplicate it. Name is right foot position. Add variable. Name it is trace alpha. Variable type is float. Add new variable. Name is foot left rotation. Variable type is rotator. Duplicate it. Name is foot right rotation. Set it to public for all these variables. Add new function. Name it set foot control. Click on entry. Add input. Name is foot location and variable type is vector. Add input and variable type is item. Name is foot control. Or set transform bone. Next execute. Next item to item. And for item get transform. Expand the transform. And expand the transform of the set transform. Set the rotation to rotation. And for the foot location, call from word vector. Connect the vector to the translation. Go to rig graph. Move this a bit. Then get left foot position. Call set foot control. Open, expand the foot control. Type is control. Name is foot control left. Connect the set left foot position to foot position. Control C and Control V. Foot control to foot control right and get right foot position. Connect it to foot location. and go to our full body IK. For the rotation alpha, we set it to 0, and put all, we set rotation alpha to 0 too. Get trace alpha, call subtract float, and 1 subtract with the trace alpha. Connect it to the position alpha of the two transform. Then create full body IK. The root is pelvis. Add effector. The first is foot elbow. Add another effector is foot or bone. Rotation alpha is 0. Rotation alpha is 0. Get trace alpha. Connect it to position alpha. Go to rig hierarchy. Get foot control left. Get control. Expand the transform. Then connect the translation. Get control right. Connect the translation to the translation. Compile and save. Now go back to ABP menu. Click on Control Rig. Set left foot position to true. Right foot to true. Trace alpha true. Foot left rotation true, and foot right rotation to true. Then add variable. Name is left foot position. Name is left foot position. And variable type is vector. Get left foot position. Connect it to left foot position. Duplicate. Rename it to right foot position. Get right foot position. Connect to right foot position. Add new variable. Name it trace leg alpha. And variable type is float. Get trace leg alpha. Connect to trace alpha. Then add variable. Name is left rotation. Variable type is rotator. Get left rotation. Connect to left rotation. Duplicate it. Rename it to right rotation. Get right rotation. Connect to foot right rotation. Compile and save. Set the trace leg alpha to 1 to test it. Go to event graph. Add pin. Get left leg. Get leg manager. And call is valid. Connect it to the sequence. If it valid, we get foot position from the left leg. Get right leg. Get foot position from right leg. Then set left foot position and set right foot position. Connect it to is valid. Let's play test. Now the character use the control rig to control the leg. Go to control rig, expand the translation, connect X to X, Y to Y, and Z. Add float with 7, connect it to Z. The same with the right leg. X connect to X, Y to Y, and Z. Add it with 7. So the leg not go inside the ground. And now it's correct. Go to third person character blueprint on event graph. Create a key 1 and then add timeline. Name it to add yaw. When we press, connect it to play from start. Open it, add float track, and then add key to the curve float. For the new track, name it to Z value. Set the time to 0 and the value is 0.2. Add key, X is 1 and value is 1. Add key, X is 1.25 value is 0.25. At key, h is 2.5, value is 1. And then at key, time is 3.5 and value is 0.2. The length is 3.5. And select all these keys. Right click auto. Click F to focus it. Set actor rotation. Split the new rotation. For the value, multiply it with 0.7 and then we add get actor rotation, split it, connect your to add and connect it to Z and then connect update to set actor rotation. Create a custom event, name it turn, connect it to play from start, and when it finishes we call its turn. Press 1 on the keyboard, the character will turn. Go to our control rig and we disable the rotation alpha. We not yet use that rotation. Set it to 0 and this one set it to 0. For the setting, root behavior, choose pin to input. We don't want the pelvis to rotate with the leg. And play test. Press 1 and then the character can rotate, but the ankle of the character is rotating with the character. Go to door, right click, blueprint interface, name it BPI anim, open it, rename the function to set and plant it. Add input, name is leg and the variable name is BP leg object reference. Add input, name is planted, variable type is boolean. ABP menu, class setting, add BPI anim. Compile. For interface, then double click on set and planted, and the leg is equal to get left leg to equal, create a branch, then if it fall, check if it equal to right leg and create a branch, connect file to the branch. Add variable, name it left planted, variable type is boolean, duplicate it, name is right planted, and if it's true, set left planted, connect is planted to the left planted, then set is planted to right planted variable if it's true. Go to BP leg, go to check for replant function, and after we set is planted to false, get anim instant, call set and planted message. For the leg is safe and is planted to fall. Go to take footstep function and is planted, we create a branch. If it's true, get anim instant, set and planted. And for the leg is safe and set is planted to true. Go to BP anim, add new function, name it set turn side, add variable input is turn side. For ABP menu, double click on set turn side and add new variable, name it turn side, set turn side to the event set turn side. Go to third person character. When we press key 1, call get anim instant from mesh called set turn sign and call turn function. Add new variable, name it turn sign. When we press 1, set turn sign to false and get turn sign, connect it to set turn sign. For key 2, set turn sign to true and call this function. Copy and paste. Go to turn event. For the z value, multiply it and select float, get turn sign, connect to tick A. A is -1 and B is 1. Let's play test. When we click 1, the character rotate right, and when we click 2, the character rotate left. For the third person character, the mesh, click on the mesh and add scene component. Name it leg right, leg off. Parent socket is foot off. Click on mesh, add scene component. Name it leg L. And parent socket is foot L. Go to ABP menu and for left planted, create a branch, get character, get leg L, get right vector, add new variable, name it default left forward. Variable type is vector and set default left forward when it's true. Create a branch, get character, get leg off, get right vector, then multiply it with converting float integer -1. Duplicate default left forward, rename it to default right forward. Set it to default right forward when it's true. And then for the sequence, after we set foot position, create a sequence, get left planted, create a branch, get character, get actor forward vector dot product and get left forward, call a cos degree, then get turn sign, select float, A is 1 and B is -1. Multiply it with the degree that come from the equals. Make rotator, connect it to roll. Then set it to left rotation and connect it to true. If it falls, we set left rotation, get left rotation, left rotator, connect it to A and B is 0, Y 90 and Z is 0. Alpha is 0.1. Click on closest path. Set it to left rotation. Get right planted. Create a branch. When the right planted is true, get character, get actor forward vector dot product, get right forward and find a cos degree, call make rotator and set it to X roll and the pitch is -90, yaw is 180. Set right rotation and if it falls, set right rotation, get right rotation, call left rotator and B value is 80 y minus 90, z is 180. For alpha is 0.1, set shortest path is true. Connect it to right rotation and connect it to fail. Go to control rig, and for the rotation alpha, we get put left rotation, convert it to from rotator to quaternion, connect it to the rotation, set the rotation alpha to 1, get right rotation, from rotator to quaternion, connect it to rotation, and rotation alpha is 1. Sorry for some of the mistake. Go to ABP menu, and for the select float, A value is -1, B value is 1, and the pitch set it to 90. Let's play test. Click 1. Now the angle of the character rotates when the character unplant the leg. And for rotate left, press 2. In the next tutorial, we will make our character know that they already turned at the door. This is the end of our tutorial, and if you have any question, please leave it in the comment section below. And please subscribe to my YouTube channel, it really means a lot to me. Thank you very much and see you in the next tutorial.